Dus. Dus remove the winner and remove the atomic from the number visited children. Still, this would run out of memory, so the non-mapped info now must be yeah, I'm still backed by a memory mapped file, I think. It would make sense to move it back to info though. But in the end, maybe I don't want to. Because it is only temporary. Okay. Let's make a second pool. I think I should rename this petitions pool. It's a bit weird, of course, to call this still non-mapped when it is mapped. What would temporary? I think. I mean, it's just, let's say, not something we want to read again. Maybe. Could call it temp infos or something. Or infos extra, maybe. Yeah, destructing it makes little sense, doesn't it? To add an empty destructor. Do that one as well. Duplicate this one. No, we should never be reusing this. Always want to zero it. So what is left then is this. Oh ja, hij removed winner. I don't know, just let's remove all winner stuff. Perfect. So we have something that works, but is not thread safe. Using two threads fails. So my plan was to create a big array of mutexes. Probably part of graph, right? Hello, toasty codes. King plus rook, so from chess. My problem here is, this is being called with, maybe, wait a minute. So it is being called for some boards. There are many boards. Many boards. Yeah, the oops doesn't happen anymore, I think. That was more a debug code, so this should never happen. And if it happens, then I print this info, but well, it doesn't happen anymore. Maybe we should remove it. The whole thing is debug code anyway. The total number of positions is so huge that it does not fit in my memory. So my plan was to make 100,000 mutexes and then just pick one of them. And then the chance that I have to use the same mutex for different positions for different threads is just not very big. No, I don't. It's Dutch, but I never lived in Nijmegen. Graph get mutexes. Okay, this is a race condition on the classification of parent info, which belongs to the board parent, which we got the info from using parent. Therefore, we need a mutex that is the same if parent is the same, so the mutex depends on parent. I think this is the right way to do it. I have to add get mutex now. So graph needs to get mutex. That takes a board. Now I already have my mutexes here. So let's add a get mutex. Why not immediately here? Standard mutex reference get mutex given some board. Definitely not const. That's the idea anyway. Maybe you can put that inside this function already. Board itself is an encoded type. I think I can convert this to an index already. Should have something like an info index, anything index. Block index. I can get a block index, and that doesn't help. Nope, I don't think we have it. I think I can just use encoded directly. So encoded type is some kind of some unsigned integer. Might as well add an accessor for that, I suppose. There is no return encoded. Not the whole thing. So we can do board get encoded and then modulo it with something being the size that I use. But now this appears twice, which is not good. So make that a constant. The mutex index. Yeah, I might as well do it like this. Let me read what you typed. You have gets and sets for the no sets. I just need to get it. So a board exists of the position of the white king, the white rook, and the black rook without encoding whose turn it is. That's why I call it board instead of position. I think position is a board plus whose turn it is. And for a very, very large board, because this is for a quarter infinite board, there are very, very many different boards. So encoded is very large, can be very large, well, a lot of different values anyway. And I just do a modulo of it, so it gets in this range. And then we pick a mutex from this vector based on that. It's kind of random, but the whole idea is that the chance that you get the same mutex for two different boards is not that big. Hell, that the cache line that you get is not that big. Not the same cache line. To be honest, I have no clue whatsoever how big a standard mutex is. You would say 1 byte is enough, but hey. I'm too lazy to actually test it. Let's believe the AI, even though it's probably going to give the wrong answer. This of course start is so ChatGPT. Holy what the mother of 40 bytes? No. That's probably with all kinds of debug stuff then. But yeah, even if it's 40 bytes, it still fits in my memory if I have 100,000 of them. Yeah, well, I kind of remember that it was very big, but probably only when you have debugging code or something like that. It's probably 8 bytes if you have maximum optimization. Oh yeah, I totally agree. It could be wrong. But like I just concluded that I don't really care, because this many is gonna fit anyway in my memory. So I was just trying to get an estimate of how many cache lines you have. Well, if one mutex is more than one cache line, then the chances that two different positions share the same a mutex in the same cache line even gets even less. I will see. So this gets a random mutex more or less, depending on the board. The only thing that really matters is that you get the same mutex for the same board. Now we don't know where we were anymore. Here, yeah, okay, whatever. I added that, that's true. Okay, hop. Get encoded is private. That was not the intention. Mixi tags. Get encoded. Let's make that public. Let's remove it then if this is private. all of that private? What the hell? It's a very private class, yeah. And then this is public, I guess. Yeah, public. Do I have any other accessor-like stuff? Not really. Well, of course not, because it's only one member. Can only have one accessor. I don't want to have anything to do with this field spec here. Oh, this is already private. And there's debug. This is friends. Let's put it here. Could make it private and then have a friend class graph, but yeah, then graph suddenly can access everything that is private. So it's always a bit difficult to choose. There is a way to make exactly and only this this member function accessible by graph. So some kind of trick for that. But all of this is just a toy program anyway, so I don't know. Let's not go that way. It just takes time. Get mutex is a private member of graph, really. Well, I had intended it to be public then, let's say, ish. Public, initialize, reset, classify, get info. Now let's add it below get info, which is probably the rest of it. Well, these look like accessors. This wasn't an accessor really, not really. I'm gonna put it here, very random place to put it. So now I'm using, or rather I'm passing a mutex to set made imply. I'm not using it though yet. Is it inline? Oh, well, this one. So you need to log that mutex and standards. Okay, I don't know. Anyone knows this? Log guard or something? I'm just guessing. It's the first thing that comes to mind. Well, it exists. Class lookup is a mutex wrapper that provides a convenient array style mechanism for owning a mutex for the duration of scope block. I think that's exactly what I want. Unique log, scoped log, deadlock avoiding array wrapper with multiple mutexes. No, I don't. We have only one mutex. Unique log implements a movable mutex ownership wrapper. No, I don't need to be movable either. It's just scoped. Scope log would be nice, but it's apparently the simplest version is called log guard. Example: create a log guard with a mutex. And then I put the const on the same side. And the mutex is called M here. Horrible name. And the logguard is defined in mutex. I probably should include yeah, I'm not sure, but let's just include it. And now what? Now this has become thread safe. Ta-da! Although we always return true. That's kind of silly. Only one thread is allowed to return true. So this is not entirely working yet. Let's read this. So the bits corresponding to a mate imply mask are initially all 0, meaning unknown, aka unknown encoded unknown ply, which is 0. Those bits are changed once by one thread to something non-zero, if and only if the corresponding position is legal and not is draw, and never changed again. The bits are only changed by this function. There is a race condition between threads, well, not anymore because you have this, where multiple threads call this function. Okay, so loads of threads are calling this. In that case, it doesn't matter which thread makes a change. Well, hang, but one passes, because it is guaranteed that all pass the same value for ply. However, only one of them is allowed to return true. Well, let's also only allow one of them to actually call this, which just sets it. But then how do I know if I'm the only one? So we need a boolean first, and then if not first, return false. So if we are the first one, aka ply was not set yet, then we set apply and we return true. First meaning that ply is not set yet, which means that encoded does not have ply set yet. That means that if I end it with made imply mask, then we get 0. I don't feel very I don't know, what's the word? It should work. There must be a better way to test if this is unknown. We had this unknown thing here, encoded unknown. So if encoded and the ply mask equals encoded unknown ply, then it's totally 0, and that means that ply is still unknown. If it's not unknown at this point, then well, someone else was first, so we return false. This should work. Now this is thread safe. However, I also changed the number of visited children. That is no longer an atomic. I need an underscore there. This used to be atomic, no longer atomic. So I want to use the same mutex for this one. I think we can safely print it, whatever it is at that point. This is totally not what I want. This is an accessor that is highly dubious. This is probably single threaded, so I might as well leave it like that. Okay, so this is just not an atomic, which leaves that. Oh yeah, and this one. Let's first fix this one and then see who calls that accessor. So this function now needs to get a mutex passed. It says, however, they should be called exactly once for each. Oh, that's testing if it is still less than. Okay. Probably should take the mutex before reading it. I mean, it's not an atomic now, so it would be undefined behavior if we read it while another thread is writing to it, which is going to happen. So we take the mutex here, standard lock guard, and the rest I forgot. Const lock. Oh, wait a minute. Lock the mutex. Now we can safely read it. Although, why would I? I might as well delete this. So now I got rid of that problem. Nobody's calling it. Okay, so we just read it directly. That must be less than children, and then we can safely increment it and compare it to the number of children. Blah blah blah. Because we have mutex. Now this should work. Yes, okay, now this one must be past a mutex. It's only called in one place. That is the parent non-mapped info. Oh no, never mind. For a moment I thought that would contain the mutex. That's totally not true. This is in info. Do we have a graph here? They don't have a graph. Well, no, then that means that we have to pass a graph. Oh, we do have a graph. Sorry, I didn't see this one. So you have a graph, so much the same as the last time. Which happened here? Ta-da. Before calling the function that needs the mutex, which was... Oh, is another call? Set made in prime, but it is single threaded. It should be working. Regardless. No, I forgot what I was looking at. Shit. Increment process children. Yep. Oh, it compiles. Well, that means it works. And it does. How about that? to switch to 32 threads. It is actually faster. Oh. Yeah. Oh, I like that. We are working in X4, I think. Which of these? Yeah, this one. So this now created a temp data of only 33 megabytes. It's almost nothing. But it's temp, so maybe I should delete that again. Instead of leave it on my hard disk. How big is this thing? It's more than 10 times larger. MD5 sum. Thank God that's all correct. Or is it? Yeah, it is. Okay, very good. Yeah, I want to delete this, I think, at the end. Let's do that in the destructor of the graph. So you have the graph. No destructor here. Graph. Well, maybe there is a destructor here, but no, there's no destructor here. Okay, let's make a destructor. Graph. And then the file name. This is the file name. We don't have prefix directory anymore, of course, but oh, we don't have prefix directory here. Probably have a data directory though. What the hell? Okay, I can just do data directory slash and then the name. It's basically data directory slash this. Nah, this standard remove file does not exist, of course. There must be also a standard file system then, but then I still don't know if it exists. remove. Remove a path. No, I think it really removes it. Linux doesn't do bins. Anyway, it's remove. Not sure what happens if the file doesn't exist at this point, but well, theoretically it should exist. So we run it again, it should be gone now. Yep, it's gone. No, good. Now I have to think for a bit. Is there anything else I need to do? Oh yeah, I wanted to make a speed up for combining. Let's maybe first commit this. We have an accessor, and we have now a mutex being passed to the problematic functions. And the problematic functions are no longer problematic. Mine and NonMappedInfo is now also using a memory mapped file. I renamed something from partitions pool.info pool. Let's rename the non-mapped stuff to temporary. Or yeah, what's a good name for that? It's no longer not mapped, it's temporarily mapped. I'm watching the Old Guard 2 movie on Netflix. That's such a horrible movie, man. So it is about immortals, and one of the immortals is locked up in an Iron Maiden and dumped in the sea. And she's there for 500 years. Like every 2 minutes, she wakes up and drowns again. For 500 years long, in the dark. Holy shit. That's no fun. Your moose asked, ampersand needed. Yes, I don't know which ampersand you're talking about. Definitely needed. If you talk about the mutex ampersand, the mutex doesn't have a copy constructor even. Now let's first do the rename. So I have non-mapped with capitals. And of course we have non-mapped. That's even more. The most in graph.h here as well. What is a good name for it? I'm gonna ask AI. Nobody's telling me, so I'll ask AI. Ephemeral. Well, I feel my IQ going up. Maybe I should use this. Transient, intermediate, scratch data, scratch, workspace. Ephemeral, meaning short-lived. Staging, temp data, that's too simplistic. Transient is a good antonym to persistent. Aux data, auxiliary, supporting role. Oh, I like that a lot, I must say. Let's look up what that exactly means. Providing supplementary or additional help and support. Yeah, I want that. Okay, so we're going to rename it to auxiliary info. I mean, I'll keep info in it because, well, it's auxiliary to info. So then I need to vi graph.h and rename all the non-mapped to, well, non-mapped info to auxiliary info. And all the non-mapped to auxiliary. Nothing. I wasted my time. What an, oh, wait a minute. That's not what we wanted. Substitute. Pattern not found. Non-mapped. Okay, what the hell? So I was slightly worried about how slow it would be to make a copy of all those vectors afterwards. So I have a task here, which is a lambda, which is pushed onto a thread pool queue and then executed, and that each task calls this function, which writes to task, well, in this case, task black to move parents, which is a vector. And in fact, well, it's a reference to a vector in an array, which is for each task has its own vector. So I don't need mutexes for it. And then when all tasks have finished, the main thread, so after all tasks finished, the main thread is adding them to this vector, to just one vector. And I'm having currently some debug code that even tests that there's no duplicates. I suppose I could delete that now because, well, yeah, it didn't happen. At the very least, I should make a debug code. So I was still a bit worried about this being too slow. We could speed this up like a lot by using linked lists. Then each thread would be adding stuff to a linked list, and then, well, concatenating the linked list is obviously like immediate. But yeah, I don't know, the access to it eventually would be slower. Or I could just use a one big linked list to begin with, and have the threads add their stuff to a log-free linked list, because the order in which they're added is not that important, really. Not important at all. So I could just, you know, get rid of this big array here, this one, a very big array, and have the threads add their stuff directly to a singly linked list, which is thread safe by design. So the question is, where is my thread safe singly linked list that is log free? Do we have that? Of course we have that, but where? Does utils have it? Does utils threading have anything? Because I can't remember it. I'm such a complete, having no memory whatsoever figure. Multiple producers, single consumer queue. Wow, that might be it. Well, at least we have multiple producers and a single consumer. I don't think so. Plus it's a queue. Probably not what they want. I need random access. So no, it's not here. What about non-threading? Something with list. I have a list here, but it's probably just a normal list. I'm getting too many utils. It's hard to find back stuff. Grep. It's just a doubly linked list. It's not thread safe. Or is it? I forgot. Ah yeah, but the power of my linked list is that you don't need the container itself. So if you want to know if an iterator is list end, which you normally want to do all the time, then normally you need an the list variable itself. Otherwise you can't call end on it. And with this implementation you can just call isEnd on the iterator directly. That was the idea, but I don't think I need that here, right? Also you can check if it is the beginning or the end. But I'm very sure I have a singly linked list that is log free. Where? Almost think that it can't be in utils because then it would have put it in threading. Maybe that. It was moved to memory. Yeah, at least it's a single linked list. Yeah, this is what I want. I mean, it's a singly linked list that is log free and thread safe. So here, allocate and deallocate are really just push and pop from the front of the list. But it's related to memory allocation, too. It's not really just a linked list, but on the other hand, we need of course also memory allocation. You need a memory pool for this, otherwise it wouldn't be very fast. Yeah, no random access would be nice though. At the very least, we need to be able to find an element at a certain offset, parent start offset. Which is more or less in the neighborhood of a fixed time times base size. Hmm. I don't know. Let's just copy it. Some reason it's working a lot better. I'm really using 100% CPU now. That was not the case before. No, this works worked like a charm. Wish it printed the mapped file though. Doesn't at all. It's very annoying. Huh? Yeah, well, I don't think I had this MD5 before, at least I didn't store it. And I don't recognize it. But let's just run it again, see what happens. "24 seconds. And it didn't write to which file it has been writing. What the F? Did I not recompile it or something? I do this. There's no way that we don't get there. Unless it did throw in the end. Maybe we should move this up. Let's do it differently indeed. I think we did throw. This probably did throw for some reason. Yeah, that also exists without debugging. So we should just print the backup file does not exist. Oh well. Okay, yeah, now it's calculating the classification of 500 gigabytes worth of positions. So that's going to take a very, very, very long time. My guess would be it's 10 or 20 times faster than to the other hard disk, which would take 15 minutes, wasn't it? So maybe 10 minutes, hopefully. And after that, it's going to do the calculation. So I don't think that's. Now I can play one game of chess, and then maybe this is finished, 1 or 2 games of chess, and then we see the progress. Then I can make an estimate of how many hours it's going to take. Oh shit! Didn't see this. With attack on the queen. Why am I doing this? Yeah, now you're thinking, come on, you're a piece ahead, give me one back. This guy is like, I want to stay my piece up. How? So Shumi goes here. Take, check. Well, if it goes back, checkmate. So he's gonna go there. Queen here anyway, threatening mate. What can he do about it? Nothing, right? Oh, the bishop could go here. Could take the bishop then, but that's not what I want. Then I sacrificed another piece. Yeah, if I take now here, he would take my bishop anyway. Let's take here. Let's just see what happens. Plus he could come forward. The usual trick. Threatening mate in 2, and the queen is attacked. Oh, look at that. Threatening mate in 2 again. could just play the pawn forward, of course. That ain't good. Oh no, it's getting away. That can't be good. Huh? I think he is running out of time because then somebody did. Oh, wait a minute. He says something, maybe. Not really. And then he has check. Let's go this way. Talking about check, I'm threatening to remove my rook. And I'm threatening to take the knight, of course. Could give double check. Take the rook. Check here. That should go mate. Definitely should go mate. I'm just not even going to calculate it. I'm so not going to calculate this. If I do this, he goes that way. That's not helping me much. Let's do this one. Yeah, I made. Well, that was fun. Cannot allocate memory. Yeah, 550 gigabyte. That's what I expected, but how can I not allocate that? Oh, why is it putting that here? Huh? Yeah, there's no room there. What? What? Well, there could have been that much room. No, used. Yeah, it's just that thing is full. Should have been putting it on number 2. What a waste of time. But yeah, one chess game takes it to the classification apparently. That's a back. Who is allocating something on back? That's G. That should not happen until this is being printed. I'm so confused. Yeah, data written too. Yeah, no way that it was this fast. Plus, it should have printed stuff. It should have printed something. Execution time 0.16 seconds. I don't think so. It only did one ply, it seems. Yeah, it did one of the 592. Max ply is 11. Is 1. Oh boy, it's a complete failure. Arrgh. For some reason it stopped after prints max ply is 1. Supply is 1, it stopped after that. Why? Well, okay, it stopped after that because why to move parents was empty. Arg, arg, arg. Shit. Just going on. I hope this part works, as in calculates the number of children that each position is and stuff. Although the hex dump showed, well, only hex 20 everywhere. Did not look very promising at all. Why is this failing? The large board. This on my other monitor so I can see it. The mouse was here. I would like to play this, but then I gotta check here. I can just go 2. I could have gone 2 rather. Shit, should have done that one. And it is not check, but now I put my queen where it would be attacked. Well, it would be an attack on my rook. At the very least, I should be able to chase it away again. So maybe I just castle long. Put the rook here. Now I can put it. Now I can play this. Insane laughter. It feels a bit wrong because I didn't castle yet, but you know, check here maybe, like check, check, check. That would not be good at all. So I'll have to take back with the pawn now. This one. Oh, you see, and then he can take here. So I have to take with my knight, and then he can give jack, and I have to move there. And I can't castle anymore. It's absolute horror. Could take that one though. program is still not doing anything. Well, it's thinking, but not printing any debugger. Yeah, that's kind of the why not move. Oh, that's why. Well, I really have to castle. Finally, we castled. You don't have time for that. You so don't have time for that. Move it again. I dare you. Okay, let's finish this. What do I just sacrifice here and then sacrifice there, and we don't have any pawns left? Maybe you can escape, or oh, I can also push this pawn with. Let's see. I could push this pawn first. Nah, just started sacrificing. So let's say I take it and he takes back, and I give check and he goes there. And then I take with the rook, why not? And he takes it there, and I give check again, and he would go with the king here. And then it's mate here with the queen. Just dude, there's no fucking, no way. It's just, I don't even need a bishop. So the plan was to sacrifice my rook as well. Sacrifice the rook, other rook. Yeah, it's just dead. Bling. Hey, hey. In that case, I want to play a new opponent, because my program is still not printing anything. You can put them program also. Oh, that doesn't work. Are you sure? Okay, I can just develop, but then maybe it castles. Is this interesting? If the pawn comes forward, then maybe we have a weakened king again-ish. Or shall I just pin the knight, after which you will probably play this pawn. And then I give check, and then this one comes, and then nothing. I can just, no, I cannot. Yeah, check doesn't do that much. I think I'll just develop. Now that, of course, is impossible. Now I can give check and the pawn wouldn't even work anymore. I think he's probably going to castle now, exactly. But... I should castle as well. Push, take, and I lost the pawn. Okay, I'll come here. I'll just go there, then. I want to sacrifice my bishop here. So the queen goes here, and then I can take there, I bet. Did not want to have my pawn. Okay. Okay, suppose I just take it, and he takes back. And then I can give double check. That doesn't help me much though. No, it's not working. Now that's annoying. I take, he takes. Maybe can go here. No, where does the knight go? And the knight could take here. It's not helping me a lot. Not at all. I have a nice check here though, or with the queen. No, then the queen is just put in front. Let me just give a check here. Yeah, that was the only move, huh? Just so you know. Running out of time. Damn, I'm running out of time. Okay, let's take this. I don't know. No, oh, my pawn is attacked. But what can I do about it? Nothing. Just give a check. Was that necessary? No, it was not even necessary. Could have given check here immediately. That would have won a bishop. Yeah, maybe this is more fun. I guess I can use this rook. Go here or there. That would be very, very, very nasty. Oh, like that. That is not bad at all. Oh, right. Very good. Yeah, totally had not seen that one. Fuck me. No time left. Oh, I should have moved my king, of course. Very necessary to defend my pawns. Oh, and I gave away that one. Okay, that was not a good plan. Damn it. I'm losing this. I'm totally losing this. It's like a program is running longer than the previous time. Strange. Okay, so how much chance do we have for a draw? Probably, well, he didn't want my my rook, that's for sure. Oh, that's lame. Yeah, no chance for a draw. For a stalemate, I meant, of course, but... Okay, I'll resign. People that really want to promote to another queen do not deserve giving mate. How long is this going to take? Now, let's see if we have a more than just hex 20 in it. Hex jump. Oh yeah, we do. It looks a lot more processed than the one that we had before. But I don't know how long this is going to take. I have absolutely no clue whatsoever. So I think I'm going to stop the stream. Just let this run. Yep, okay. I'll be